In the last video, we'll discuss about domain problems, and I think I have given you a few problems. Let's discuss those problems first here. The problem was log x log 2 1 upon x minus 2. This was the function defined by the fx, right? Now, for finding this function, we have studied about the logarithm functions log ax. For this domain, x should be greater than 0, a should be greater than 0, and a is not equal to 1, right? Now, here applying this, that means for this x space, x should not be equal to 1 and x is greater than 0, right? First thing we got this. Now, and this is the quantity which is x here, that means this quantity greater than 0, therefore log 2 1 upon x minus 2, this quantity, right, should be greater than 0, therefore we make it as greater than 0. 2 is greater than 1, therefore the sign of inequality will not change. 2 moves here and becomes 1 upon x minus half greater than 1, right? Now, do not cross multiply here. Instead, let's bring 1 this side greater than 0. Now, taking the LCM, you get 1 minus x minus half upon x minus half greater than 0, or say x minus 3 by 2 upon x minus half. This is negative, the sign will change, less than 0. We call this got this conditions here. Now, first it was and second this. Now we have to take the intersection of both the conditions. Now let's draw the number line. X minus 3 by 2 and x minus half. This is half and this is 3 by 2. Using for second conditions, it is positive, negative and positive. Therefore, the required region is this. X minus half is the denominator and it's less than 0. Equality sign is not here, and obviously in denominator 0 kabhi ho bhi nahi sakta, so will not include these two things. And the intersection with x greater than 0 and not equal to 1. X greater than 0 is what? This x greater than 0, and it's not included 1. The 1 is here, this should not be included. Therefore, x belongs to half to 3 by 2 minus 1. This is the required domain of this function. Got it? Now the next problem, y equal to under root of x square minus mod x. This was the problem, plus 1 upon under root of 9 minus x square. We need to find the domain. Again, it's a combination of two functions. Let's find the domain of this function, 1 upon under root of 9 minus x square. This is the quadratic function, and therefore under root of 9 minus x square, that means 9 minus x square should be greater than or equal to 0. We'll eliminate the equal to sign because denominator cannot be 0. If denominator is 0, the function will not define, therefore will not use the equality sign here, right? In the square root function, thing should be greater than 0, greater than equal to 0. Here should be only be greater than 0. So x square minus 9 is less than 0, and x minus 3 and x plus 3 is less than 0. Right, this is the first thing that we have solved. Now for this thing, x square minus mod x, whenever we got the mod x quantity type of quantity, first this is square root, we'll solve this like x square minus mod x greater than 0. Now we have the modulus quantity. The modulus quantity, we generally take the two cases. Case 1, that means x greater than 0, function become x square minus x greater than 0, x into x minus 1 greater than 0, right? This is case 1, x greater than 0 and x into x minus 1 greater than 0. Now we'll take the intersection of these two cases. This become what? Let's draw on the number line. X is 0, 1. This is positive, then positive, negative, positive. Right? So reason is this and this. This is equal to sign here. This would be equal to and this would be equal to. So we've got the including sign here because what's in the numerator. And x is greater than 0. For the second case, x is greater than 0. Right? Case was x is greater than 0. Therefore, taking the intersection here, let's take the case here x greater than equal to 0. Now taking the intersection here is x belongs to 0, one case, plus 1 to infinity. Right? We'll get the case here. Now second case, case 2, when x is less than 0. Now the equation become x square plus mod x becomes mod x become plus x is greater than 0, equal to 0, right? And in this case, x into x plus 1 greater than equal to 0. Now let's draw the number line. This is 0, this is minus 1, this is positive, negative, positive, right? And this is x less than 0. So it says this conditions and this conditions, right? Here x less than 0, here we included it into 0, here we not include. Now the answer here is x belongs to minus infinity to minus 1. We have intersected the two things, case and this value here. So we get the value minus infinity to minus 1 here. Here 0 plus 1 plus 2, 1 to infinity, right? So we have taken the two cases. In these two cases there would be a union thing. Now let's plot these two values and this with intersection with this value. Here it shows x minus 3 and plus 3, minus 3 and plus 3 less than 0. That means was the reason. This was the reason, minus 3 to 3, right? And the condition here was 1 to infinity. 1 here is this 1 to infinity, and here is minus 1 to infinity, right? 1 to infinity and minus 1 to infinity including 0 also. Therefore here x belongs to minus 3 to minus 1, which is included, union 1 to 3 union 0. Therefore domain of this function is, we have included these two cases and as well as this. So this is the case overall, and we got the answer minus 3 to minus 1 union 1 to 3 union 0. Now the next problem, fx equal to sine inverse of x square plus x plus 1. Now this is the inverse function, so I'll say x square plus x plus 1. That means sine inverse x square plus x plus 1 means this things belong from 1 to minus 1, right? Because sine function is maximum value is 1 and minimum value is minus 1. So this is x square plus x plus 1 is from minus 1 to 1. Obviously under root is always greater than 0, therefore no need to use this sign, or more customized I can say this is from 0 to 1, because negative thing is not possible here. Now x square plus x plus 1 is from 0 to 1, that means it's a positive thing. Now I can remove this under root sign here. I can say now x square plus x plus 1 is less than equal to 1 and greater than equal to 0, right? And x square plus x plus 1, this is the quadratic thing. X square plus x plus 1, it's a quadratic function whose a is greater than 0 and d is less than 0. Therefore this function is always positive. This is always positive. Now not to, that means this condition x square plus x plus 1 greater than equal to 0, this is satisfied for all values of r or all values of x. And the second condition is here x square plus x plus 1 is less than equal to 0. That means x square plus x is less than equal to 0. X into x plus 1 is less than equal to 0. This is for all real values, and if solving this is for x1 to x plus 1 less than 0. That means 0 minus 1 and 0, positive negative positive. We have to find the negative value, therefore x belongs to minus 1 to 0, and obviously both would be included. The domain of this such function is minus 1 to 0. Now let's come to the next problem. Y equal to under root of sine x minus under root of 16 minus x square. Now again, so combination of two functions, 16 minus x square, that means square root, that means 16 minus x square has to be greater than equal to 0, or I can say here x square minus 16 is less than equal to 0. That means x plus 4 into x minus 4 is less than equal to 0. I'm writing directly. You draw the number line here. X belongs from minus 4 to, which is 4, minus 4 is included, to 4 included. This is the solution of this. Now we have to do the intersection, because algebraic sum of the two functions here is under root of sin x. That means sin x should be greater than 0 or equal to 0, and we know that the maximum value here is 1, right? Now let's draw the graph of sin x. This is the rough graph of sin x, and this is the value is 0, this value is pi, and this value is 2 pi. Here is minus pi and minus 2 pi. Right? Now this is sin x is greater than or equal to 0 is positive for this case. Here it's positive, here positive, and again here it becomes positive. Now we have to take the intersections, right, of these positive quantities. This belongs from minus 4 to 4. Now I am taking the intersection. Look it carefully here. I'm taking the intersections, right? This is minus 4 to 4. Let me try to plot this minus 4. This is minus pi. Minus pi approximate value is 3.14. Therefore minus 4 would be somewhere here, and 4 would be more than pi, that is here somewhere, right? Pi is 4 is somewhere here. Now we have to find the intersection. For the positive quantities, minus 4 to minus pi, this function is positive, right? And from 0 to pi, its function is positive. After pi, it becomes negative, right? So we have to take the only positive things. Therefore domain here is x belongs to minus 4 to minus pi union 0 to pi. Amazing question, because many of the students do mistake in this type of questions. This is algebraic, this is trigonometry, and you have to realize we have to use your pi. Do not use 90 degree here. Always use the value like pi, and the pi value is 3.14, and compare it with the 4 and minus 4 here. We have compared it, right? Next, y equal to 1 plus 3 upon x raised to power 1 upon x minus 2. Whenever you get the exponent functions, what you have to do, whenever you get the exponent function, say a raised to power x, what you do, make a greater than 0 and x belongs to a real number, and we'll get the domain here. Similarly, what we do here is 1 plus 3 upon x, will make it as a positive, first thing, and second thing is 1 upon x minus 2 belong to, and that means x minus 2 belongs to real number. That means x is not equal to 2, because when x is 2, the denominator becomes 0, and 1 plus 3 upon x greater than 0, it means x plus 3 upon x is greater than 0. Now let's plot this. This is x, this is x plus 3, that means minus 3 and 0 are the critical points, positive, negative, and positive. Therefore intersection of these two things, x is not equal to x not equal to 2, that means x belongs to minus infinity to minus 3 union 0 to infinity minus 2. Hence the answer is this. These are the many problems of the domain. If you have some problems about the domain, just post the comment over the video. I'll try to give you a solution. For the homework, in next video we'll discuss about the range, and for the homework, note down this question. If you're not able to solve it, just post comment, give you the solution. Find the domain of this function. Log sine inverse of log of x to the base 2. Find the domain of this function, right? Next video we'll discuss about the range, how to find the range of the function. Thank you.